Hey, ninth graders. Okay, we are on the notes titled Scatter Plots in Technology. This should be page, I think it's 48 in your math binder. Okay, so we're going to start at the very top here. It says the following table shows how a person's pupil diameter changes over time. So your pupil, if you look at your eye, is inside the color part of your eye. You have like a black circle, and that's your pupil. And that's the circle that, like, if you were to be outside when it's really bright, that circle would get smaller to protect your inner workings of your eye. And in the darkness, it gets bigger. But the average size of it, the diameter of it, changes as you get older. And what do you know happens to your eyeballs as you get older? Well, your vision starts to get poorer and poorer. So that's what you can measure on here, is that the pupils are actually changing as your eyesight gets older and potentially worse. Okay, so we are going to create a scatter plot of the data. And whenever we create a scatter plot, the first thing we are going to do is label the X and the Y axis. So I know that the first thing given to me is always going to be X, almost always. This is our age. That's our independent variable. Your age changes no matter what. And the diameter of your pupil is changing with your age. So that's going to be our dependent, or our Y value. So down here on the bottom, I'm going to leave enough space to number this, but I'm going to write age along the X axis. Let me focus that, it looks a little bit blurry. And then along the Y axis, I'm going to twist my paper and label diameter. And I could probably write pupil. Why not? Okay, so we got pupil, diameter, and age. All right, so I know that the ages, looks like the youngest age is 20, the oldest is up to 80. So I'm going to count by tens along here. So let me remind myself that it starts at 0, because you can have a 0-year-old, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. I almost wrote 1,000. Don't write 1,000. I'll erase that so it doesn't look like I wrote 1,000. Okay. On the Y-axis, we are going to put our pupil diameter. Now the biggest pupil diameter goes up to about 4.7, and the lowest is somewhere around 2.3. So I'm going to count by ones, but I'm actually going to skip a space in between. So technically I'm counting by 0.5. So I've got skip a space and then 1, skip a space, 2, skip a space, 3, skip and then 4, skip and then 5. Okay, when I try to plot these, I've got a 20-year-old with a pupil diameter of 4.7. So I go to the right 20, go up to 4.7, which is almost to 5, and I draw a dot there. The 30-year-old was 4.3. So I go past 4 up to about 4.3. The 40-year-old was 3.9. The 50-year-old was 3.5. The 60-year-old was 3.1. 70-year-old was 2.7. And the 80-year-old is 2.3. So it looks something like this. All right, now you can see how this data is lined up. What would your sentence be to describe the relationship shown in this scatter plot? Remember, we have to decide, is there a positive correlation? Is there a negative correlation? And then between what two variables? Please make sure you put them in the correct order. So push pause, write your sentence. All right, check your sentence with what I'm going to put here. There is a negative correlation between pupil diameter and age. Now remember, we had negative correlation there, and the negative correlation is because this is a downhill slanting graph. And then we said between pupil diameter, because that was the y-axis, and age, the x-axis. You always do y per x. Okay, we are going to also give an estimation for our correlation coefficient. So I want you to estimate what your correlation coefficient would be here. Now I keep saying correlation coefficient rather than the letter because sometimes when I say the letter, you forget what the title is for that letter. So let me remind you, if you've forgotten, we are estimating our correlation coefficient, which is R. What would you say about R from this graph? Well, I can see that this graph goes pretty steadily downhill, so I know R is going to be a negative correlation coefficient. Notice I put the estimations because this is not an exact number. I am literally doing a quite educated guess, but that is almost perfectly in a straight line. But I don't know if it's exactly in a straight line, but it's really, really, really darn close. I want you to put your estimation of what you think R is. Maybe it's 0. Blah, 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 probably a very high number in the negatives, really close to 1. And we are going to calculate it and see how close your estimate was. So I'm going to let you make your estimate there. And now I want to show you how to find that correlation coefficient using our graphing calculator. Now last year, my students used the graphing calculators that were in my classroom, and they're great calculators. If you have one at home, you're welcome. Let me just remind you what it looks like. If you have one of these TI-83 calculators, or even if it's TI-84, you should be able to follow along with these steps. However, remember, we are using a Desmos calculator this year online, and what's really cool about this calculator, the Desmos one, is you're allowed to use it on your end of year testing with the ACT Aspire test. At least that's how it's been in the last few years. We've been given that calculator to use. So I'm going to show you how to practice this on the calculator that you are allowed to use, which is desmos.com/calculator. And you are going to see where we can get the correlation coefficient and a lot of other really, really, really great information. So I am going to have you follow along. I'd like you to also keep track of this, maybe open up your own calculator page. Let me figure out, I gotta stop sharing this. And hello, I'm going to share a new screen. Okay, you can see my screen right now. And this is just a basic desmos.com/calculator. Now remember, if you want the keys to show up, you can just click down here where it says show keyboard. And then all of this stuff shows up. And then if you want, actually the next part you're going to need to do is click add item. And we would like to put a table in here because you have all of these wonderful values from your notes for today. So we are going to put all of that data into our table. So I'm going to put age along the X numbers. So I'll start with 20, and then if you push enter, it'll take you down to the next one. Then we have the 30-year-old. Oh, wow, I didn't know that it does this. Do you see how it put in 40, 50, 60, 70, 80? What? Desmos, thanks for loving me. Okay, over here, it's not a pattern. 4.7, and then 4.3. 3.9, 3.5, 3.1, 2.7, and 2.3. On your homework, it might be a good idea to double check that you type in the numbers correctly. Okay, when this is filled in, I want to show you what this looks like. I'm going to zoom out. Do you see how my graph is on there? That's pretty crazy. Does that look like the graph that we have? Probably not. It does not look like our graph. So let me explain why our graph looks different. By the way, if I click this button, the graph disappears. If I click it, it reappears. Let me remind you why our graph looks slightly different. So if we come over here to settings, we can make it so it does not show the minor grid lines if you'd like, or we can make it so it does. But I can tell my graph what to make the x-axis. So if I say that I want the lowest that x goes to be 0, and if I want the highest that x goes to be 5, just like our graph, and I want it to step by, oh, hold on, that was not what I wanted. I wanted that to be on the y-axis. The y-axis, I want it to go from 0 to 5 because that's what we had on our graph. And if I have it step by 1, that means it's counting by ones. And then the x-axis in our picture went from 0 to highest age we had was 100. And we had it step by tens. That means it's counting by tens. So let's see if this looks a little bit more like ours. Oh, of course I scrolled out. Yeah, this looks a lot more like ours. It's almost perfectly in this beautiful straight line. Let me remind you one more time, you can get rid of these minor grid lines. And then it really does look quite a bit like our graph, where we had the half spaces in between. And I think our graph even did put, hold on, ours didn't step by 1, it stepped by 0.5 because we had the half spaces. Anyway, all that to show you, yes, this is what our graph looked like. Okay, so now I want to show you how to get that R value. So we are going to use the data over here, Y1 and X1, and I'm going to write Y equals MX plus B, but I'm going to make it very careful. I'm going to make it use this Y and this X when it calculates Y equals MX plus B. So let's write Y1, but I want to get an approximate equal. So there's a button on your computer. Watch the one that I type. It is above tab, and if you push shift and that button, you get this swirly like dash, like a backslash that has like this little swirly on it. So click that, and then you are going to put M, and then X1, and then we're going to put plus B. Do you see this black line that just showed up? That black line is the calculated line of best fit. So that line looks like it lines up really well. And if we look underneath it, do you see how it says statistics? R squared is 1 and R equals -1. Oh my gosh, remember how I said that it wasn't probably -1? I was so wrong because it was -1. But then they also gave us a value for M and they gave us a value for B. Now I would like to keep this all in mind, and let's see, let me pause this really quick. Get you in the corner. 1 second. Okay, so we are going to put our correlation coefficient in there. It says round to the nearest hundredth, or 1,000th. That would be 3 spaces after the decimal. But as you notice, we didn't have to round on that one because our R in our Desmos.com calculation was -1. So what does that value tell us about the data? Well, remember back to when we said like strong, moderate, or weak? Well, this is like strong. This is super strong, like very, very, very strong because it is the strongest possible negative correlation. So we would say very, and I'm going to underline the word strong, very strong negative correlation between pupil diameter and age. So just by looking at the last part, we are able to say, yeah, there's a negative correlation. But once we have that R value being -1, that tells us that not only is it a strong correlation, it's like super, extremely, perfectly strong. Okay, so then it says use your calculator to find the line of best fit. So we are going to have an equation that is going to start with, hold on. Actually, what we want to take from that calculator that we just had on Desmos, we want to get an M value and we want to get a B value. So I'm going to go back to my calculator. I'm going to stop this share and I'm going to share my screen with you. And let's pull this M value straight from here. I'm going to write that on my paper. -0.04. And my B value right here is 5.5. Super important numbers. And by the way, you can also toggle this on and off with Desmos. That is our line of best fit. So this M and this B are going to be used with our line of best fit. That's why it's called a line of best fit here. So let's switch back to my paper. And when I write this down, I can say that our Y equals, but instead of MX plus B, I'm going to say negative, and you can write 0.04. I'm just going to write -0.04 x plus 5.5. Okay, now it says describe in words what the slope means in this context. So in this context, our slope right here is our negative 0.04. So this is telling us how our rise over run changed. So if we've got negative 0.04 technically over 1, that means that it is decreasing 0.04 per one x-axis. So if we look back at our graph, this line of best fit is going down 0.04 to the right 1, down 0.04 to the right 1, down 0.04 to the right 1, down 0.04 to the right 1. It's going down 0.04 pupil diameters to the right 1 year of age. So I would say pupil diameter decreases by 0.04, or you could say by negative 0.04, it's fine, millimeters per year. The only reason I didn't put a negative there is because I said decreases, which is our going down 0.04. Okay, so then it says, describe in words what the y-intercept means. So our y-intercept was 5.5. Let's use that. And we are going to write our ordered pair. So 5.5, it's really 0, 5.5. So what would that be as an ordered pair? Well, our x-axis was age, our y-axis was pupil diameter. So if this is the age, it would be 0 years old, and that would be the pupil diameter. So at 0 years, pupil diameter is 5.5 millimeters. Is that true? I don't know. I've never measured the pupils of a newborn baby. Okay, so use the prediction, or use the equation to predict the daytime pupil diameter of a 4-year-old. So let's figure out where 4-year-old fits. A 4-year-old is giving you the age. So they gave you an x value. So I'm going to go to that equation that I was given, but instead of x, I'm going to put in the number 4. So we will write y equals negative 0.04, but again, instead of x, I'm putting a 4 plus 5.5. Okay, I don't know where I put my calculator. Found it. Okay, let's clear this off. Negative 0.04, or you can type in 0.04, it's fine, times x, which is 4, plus 5.5. And we get 5.34. So the y would equal 5.34. And I'm assuming again that it's millimeter. So on this problem, do you think that there was causation? Do you think that your age is causing your eyesight to decrease? Do you think it's just random coincidence that the two things move together? Or would you say that someone's age is clearly causing their eyesight to decrease or their pupil diameter to decrease? I want you to write your reason here because you're going to explain it in just a second. I don't like to write in reasons for the causation because I think that that's something that you really do have to answer on your own. Maybe you are thinking to yourself, yes, as you get older, clearly this picture is showing that your pupil diameter changes, and we know that as you get older, your eyesight changes. So age does affect eyesight. Or you can say, no, these two things are perfectly not connected. Your eyesight could be really good when you're older and not decrease. So whatever reasoning you've got, make sure you write it down. There's something else that I would like you to write down over here in the margin. I want to remind you that when you go to this stuff, we are using, I'm going to write my paper sideways. We're using desmos.com / or just regular / calculator. And you are going to click the plus sign and table. Type in X and Y. And then once you type in X and Y, the next line you're going to say Y1 is approximately equal to M X1 plus B. That is the super important part that you cannot forget. So I'm going to highlight that around it in yellow. Don't miss that. Okay, once you have that written down in your margin, let's come back over here and we are going to write some stuff on this. When I keep telling you how to talk about the slope, on our slope, let's write slope. I know sometimes people have a hard time coming up with these sentences, and these sentences are going to be required as you do these problems on the test and everything. So slope is always referring to m, and you are going to say the y-axis, and then you are going to decide either increases or decreases by m per x-axis. So this is like a general rule for how you write this. So on here, our y-axis was pupil diameter. So we said pupil diameter, and since it was negative, it decreases by our slope number per x-axis, which was year here. Okay, then let's talk about what the y-intercept would be. The y-intercept is always going to be an ordered pair. It's always going to be 0, comma, some number b. Okay, so you would say at 0 x-axis, the y-axis is whatever that b number is. Okay, one more thing that I want you to put over here in the question/notes, and we've had this before in our notes, but I want you to get this memorized. Strong correlation will be from 0.70 to 1.00. Moderate is going to be from 0.40 to 0.69, and weak is going to be from 0 to 0.39. So we've got strong, moderate, and weak correlation. All right, I'm going to have you close this out and answer the question that is written for today's assignment. Yeah, good luck, ninth graders.